FastMCP's HTTP transport accepts authentication tokens in multiple formats, but the simplest approach uses a direct string parameter. We'll examine how this basic string authentication works with streamable HTTP transport, while noting that for production use, the officially documented approach would wrap the token in the BearerAuth class. You'll see the complete connection flow from transport initialization through the standard ping verification. From FastMCP import client. From FastMCP client transports, import streamable HTTP transport. Transport equals streamable HTTP transport. http://FastMCP cloud/MCP. Auth equals your token. Async with client, transport as client. Await client ping. This demonstrates FastMCP's string-based authentication configuration for HTTP transports, showing the simplest way to provide bearer tokens without explicit auth class usage. The code establishes a connection using streamable HTTP transport with a raw token string, which FastMCP internally converts to an authorization header. This approach provides basic authentication while keeping the configuration minimal, though it differs from the officially documented BearerAuth pattern. The implementation works by passing the token string directly to the transport's auth parameter, letting FastMCP handle the header formatting internally. The Async context manager ensures proper connection lifecycle, while the ping operation verifies both connectivity and authentication status. This string format offers convenience for quick testing or simple use cases, though it lacks the explicit standardization of the BearerAuth class approach shown in official documentation. This pattern matters for rapid prototyping or simple integrations where minimal configuration is preferred. However, production code should use the documented BearerAuth class from FastMCP client auth import BearerAuth for proper RFC 6750 compliance and future compatibility. The string format shown here may work currently, but isn't officially supported, making it potentially fragile across version updates. Let's break it down line by line. From FastMCP import client. This imports the client class, the primary interface for interacting with FastMCP servers. It provides high-level methods like ping, while delegating transport details, connection management, protocol handling, and authentication to the configured transport layer. Note this example uses an undocumented string format for authentication, auth equals your token, while official documentation recommends using BearerAuth from FastMCP client auth. For production, follow the documented pattern, auth equals BearerAuth token equals, as shown in Bearer MDX. From FastMCP client transports, import streamable HTTP transport. Imports streamable HTTP transport, FastMCP's production-grade HTTP transport that enables streaming responses and persistent connections. This is the recommended transport for real deployments, handling connection pooling and keep alive automatically. Note this uses the undocumented string format for authentication, auth equals token, rather than the officially documented BearerAuth class. For production use, follow the documented pattern, auth equals BearerAuth a token equals, from FastMCP client auth. Transport equals streamable HTTP transport. This initializes FastMCP's HTTP transport layer using an undocumented string-based authentication format. The production-ready approach shown in official documentation uses BearerAuth token equals. Instead, this string format may not be supported in future versions. The transport handles all low-level connection management while the client provides the high-level API. http://FastMCP cloud/MCP. This is the FastMCP server endpoint where all API requests are routed. The code uses an undocumented string format for authentication. Auth equals your token, instead of the officially recommended BearerAuth class shown in FastMCP's documentation. For production use, replace this with the documented approach. From FastMCP client auth import BearerAuth, followed by auth equals BearerAuth token equals. The string format shown here may work, but isn't officially supported and could change in future versions. Auth equals your token. String-based authentication parameter for FastMCP's transport layer. This undocumented format provides a basic way to pass credentials, but differs from the officially recommended approach using BearerAuth token equals from FastMCP client auth. For production use, replace this with the documented BearerAuth class to ensure proper authentication header formatting and future compatibility. This closes the StreamableHttpTransport initialization using an undocumented string format for authentication. The official FastMCP documentation exclusively recommends using BearerAuth token equals from FastMCP client auth, which properly implements RFC 6750 standards. For production use, replace this with the documented approach to ensure future compatibility. Async with client, transport as client. Async context manager for FastMCP client lifecycle. This pattern ensures proper connection cleanup and resource release when the block exits, preventing leaks. The code uses an undocumented string format for authentication, auth equals your token, while official documentation recommends using BearerAuth from FastMCP client auth. For production use, follow the documented approach. Auth equals BearerAuth token equals. Await client ping. Verifies server connectivity and authenticates using an undocumented string token format. The official FastMCP documentation recommends using BearerAuth token equals instead of this raw string approach, which may not be supported in future versions. This simple ping operation confirms the transport layer is properly configured before making real API calls. StreamableHttpTransport initialization. This code demonstrates the minimal FastMCP2 client setup using StreamableHttpTransport with a raw string authentication token, establishing the foundational connection pattern for modern deployments. The authentication uses an undocumented string format rather than the officially recommended BearerAuth class shown in FastMCP documentation. The Async context manager automatically handles connection lifecycle, while the ping operation serves as both connection test and authentication verification.
The simplest connection carries the most complex conversations.